Okay, so this is the next question that we got on the menu today. It's asking us write the logarithmic expression of a single logarithm with a coefficient of 1 and simplify it as much as possible. And what we're given here is 8 log 3x minus 2 log 3x minus 7 log 3y. Okay, cool. So we want to simplify this, which should not be too difficult, okay? So it says that we need a coefficient of 1. So the first thing that I think would be a reasonable thing to do is that we convert all of their coefficients to 1. Coefficients to 1. Okay, so how we can do that is, let's say we have a times log of m. We could rewrite this as log m to the power of a. Okay, so we can move those coefficients into the powers of the argument, and this will help us eliminate all the things in here. Okay. Oh, I think. Oh, whoops. There are a couple different ways that we can interpret this. I think the given answer here, interpret it as the base, but we can interpret these as having a coefficient 2. And also that's z instead of x. Whoops, my bad. Okay, if this is the case, it is nothing to worry about. We can keep it as is. Cool. So let's just go with our assumption that we've written here. Of course, it would be perfectly valid if everything was base 3 and we just wouldn't have these 3 coefficients. But let's keep it like this, and we'll learn a little bit more, because we'll see what happens to those coefficients when we apply these log laws. Okay. So for the first one, we know that for the first term, we want to bring the 8 into as the power of here. That's going to be log. Now remember, it's everything inside between the brackets of the log. So it's going to be 3x to the power of 8. The 8 came from there. Okay, now we want to convert this to a plus. Why do we want to convert this to a plus? It will make things a lot easier. Otherwise, we're going to have multiple divisions. But I mean, I guess the difficulty is about the same. But my preference is to convert everything to positive, so that we just multiply it together. So in here we have 3z, and this is to the power of negative 2. Remember, I brought the negative there with it. Okay, and the last term we are bringing the 7 over, so we do plus log. Now we have 3y to the power of negative 7. Okay, now I brought the negative over here as well. So I'll just write here, convert to positive by bringing negative into the exponent. Okay, so let's simplify this a little bit. So here, the x is going to remain like x to the power of 8. But the 3, we do 3 to the power of 8. So that is 30, that is 65, 61, x to the 8, plus log. Now, we can convert everything into a positive exponent if we just do, here we'll have 9z squared So pretty much you did it just as you would normally, as if it was positive 2, but you send it downstairs on the fraction just because it's negative, okay? And then plus log. Now we'll have 1 over y to the 7, but it's got a coefficient on the downstairs of 3 to the power of 7. So 3 to the power of 7, 2187. Okay, cool. So this is our next intermediate step. Now the next thing that we want to do is that we know that if we have log with the same base of m plus log of the same base with n, this is equal to log of the base of m times n. Okay, so if we have them added together, pretty much we can multiply all of their in bracket stuff together and make it a single log. And the coefficient is already 1 because that was our first step. So that brings us one step closer to victory. Here we got log. Now we just got to multiply all of the in bracket stuff together. So here on the upstairs we have, or we can show this more explicitly. So 6, 5, 6, 1, x to the 8. Multiplied by 1 over 9z squared, multiplied by 1 over 2187 y to the 7. Okay, and that's all in bracket. So we can do some simplification. So let's do the real numbers that we have so far. So we do 65, 61 divided by 9 divided by 2187. And this gives us 1/3 multiplied by x to the 8 over z squared y to the power 7. Okay, so I suppose we could write it like this. And we don't really need the 1 up here, so this will be our final answer. Okay, so let's circle this off. Final answer, assuming that the original 3's were coefficients. Okay, here in the given answer that we have, it was assumed that the 3 was a base. Honestly, you can't really tell like this, like you want to format it more properly to be more precise, but now we have a way of solving it either way. So this would be using 3 as a base, and this would be using 3 as an exponent. Okay, cool. So, above solution is good. Oh my goodness. Assuming 3 are bases, covered, used 3 as a coefficient. Okay, cool.